Yeah, not sure what was going on, but it seems that it wasn't working. But I think now it is. So I'm going to spend 30 minutes continuing the examples on assembly x86, and then I'm going to follow the tutorial on Haskell. I think I'm going to try to do the basics on Haskell, the basic tutorial that I have here. I haven't read, so I'm not really sure. I think it's just like a very small tutorial. This tutorial here. I already tested, so downloaded I installed the compilers, I think, and I think I clicked on one of these links, and it's basically a PowerShell command that you have to run to install the compilers. And I tested on the command line, but I haven't tested on creating the file. So I'm going to just test a simple example, and then I'm probably gonna. I wanted to avoid learning Haskell because, and there's also so many functional programming languages, but I think it's kind of unavoidable because most of the, not most, but a lot of the papers on compilers and stuff related to compilers is written in Haskell. So I think it's just a good idea, and uh, it is a good idea to learn, but I'm gonna try to avoid spending a bunch of time. So I just learn enough so I can understand the compilers and other examples that I may encounter, but try to avoid spending too much time. So I'm probably going to, after I do the example there, if I can do it, because I haven't tested, obviously. But if I can do it, I'm probably gonna open VS Code here. I think I'm gonna put the example. I was thinking about creating a folder for Haskell, but I think it's probably gonna be better to try to look into the projects. I don't remember which one is which, but I think that I have the GitHub repos open here. So I'm gonna see which ones of these. I think all of these, as far as I remember, are compilers. So this is obviously TypeScript based on the name here, but I think the other ones are in Haskell. Right, like these three, probably both QTT type theory are in Haskell, and these ones are TypeScript and JavaScript. So I'm going to spend some time reading the code and then see if I can execute the files or compile the files. I'm just gonna wait to see. So just before now, I tried to start streaming and then it wasn't working on OBS. Now it's saying that it is working on Twitch, seems to be working, but I'm gonna wait to see if it's streaming on YouTube. Yeah. So I'm gonna start with the examples on assembly. I put half an hour, and I'm just gonna continue the list that I have there. Let me open the list first. I think it's really. So I'm gonna do half an hour of this. Start application. So basically, it's pushing through the stack. And this one is very simple, so just using imove. I think imove is for signed multiplication, I think. Yeah, so it has to be because it's both integers. So this is not interesting. We're just gonna see if the negative changes anything. It's basically pushing the values to the stack there, and then from the stack to the registers based on the offsets, and then just calling imove. So it pushes one of the values to EX, then uses the other one from the stack to multiply the value on EX, and by convention it's gonna return the value on EX. So very similar, but this one pushes to the register first, then pushes to the stack, which is basically the same pattern from the other examples. So I'm just gonna copy the other here, but I think the main difference between this one and the other is going to be that this one's probably uses move. Move is for unsigned multiplication, and imove is for signed. The thing that is confusing about multiplication and division is that they use two different registers to put the result when the value exceeds the value of the register, I think. So I think that the other examples there are with higher numbers, so it's going to be more interesting. But apparently he's using imove here as well, which is interesting. It uses imove as well. So how does this work? I'm passing a negative value here? How is this possible? That's just gonna... shouldn't it give a break on the compilation? Therefore I can see the value on EX. There's gonna be also, I think it converts automatically as well. But it's gonna be on the register, so I can see the value. Hmm. Also, it's because when you convert, the negative numbers are gonna be... So use the choose complement representation of the negative number, I think, which is gonna be this value here, and then when this gets converted into unsigned, it's gonna be a very large number, because that's how it works. Because obviously on one side you don't have the choose complement representation here, I think. So it's interesting. I wonder why he's using imove even on this situation. think this is probably just more effective. Yeah, whatever. I'm just gonna go over the other examples, and then if there isn't anyone that uses Moo, I'm gonna try to see if I can get some code from ChatGPT or think about variations of code to get assembly code that is gonna use the Moo instructions. So I should probably pass some large values here and ask ChatGPT. So it doesn't compile. Interesting. I guess yeah, it's because I copied. Yeah, that works. The problem with this is that I can't see the result. For this case, it might be better to just use the compile again there and then just use x64 dbg to see what happens on runtime. So I think I'm going to do this. So obviously it's very similar to the other examples. So it's pushing the arguments. This compiler here pushes to the stack and the other one usually pushes to the res or moves to the register. So it's pushing to the stack before it calls the function, and then it has the offsets based on that. And then, so A and B is basically going to be the values of the parameters. So it moves that to the EAX and then multiplies with B. So multiplying the two different values. And storing the result here, I think. But I think that the iMove, so maybe we're gonna ask GPT or search somewhere. Like the menu is kind of annoying to see because there's like the menus that they have, the menus that Intel has are very large, so it's kind of, and there are PDF files, so it's kind of hard to search for the information. But there are cheat sheets, which is easier. But I'm pretty sure that the IMO instruction is gonna be, the result's gonna be on two different registers. I think it's RDX and RAX, or yeah, on 64 bits, and then obviously on 32 bits, it's going to be EDX and EAX. So like one of the registers stores the most significant numbers, and the other one stores the other ones. Because the fact of multiplication is that the amount of bits you need is going to double after the multiplication. Yeah, so is it the RDX and RAX? So I did say correctly, I think, if I remember. It looks like it compiled. So I'm gonna open x64 DBG and I'm gonna see if I can. The problem with using x64 DBG is that last time that I went over this, I wasn't sure if because sometimes it seems like there are some weird situations where sometimes it seems it's running two different threads, so the code jumps in a weird way, and other times it goes through function tables or something like that. So it's kind of hard to know for sure if I'm looking into the correct code there. So I just opened the executable. I compiled here using this file. So I explained this a bunch of times, but it's basically really simple. The most annoying part of using CMake is when you're gonna use external libraries, but if we're not gonna use them, all I have to do is put add executable, then the final name of the executable that you want the executable to have. Then you put the C++ files that are gonna be used to create the executable, and you put, if you're using any header files, you put this target include directories, and then you put these patterns here. This is environment variable from CMake that allows you to get access to the current to the path of the CMake file. So it's basically the root of the project here, and I'm putting them on the include. But most of the examples don't have this, so I'm just adding the executable, and then it puts everything on the build folder here. The final executables for each example that I have there. And then you just use x64dbg to open them. And I think you can click on this arrow here to go to your code. So I think that's what is going on. So here is better because you can look into the registers there, but I'm not 100% sure like I saw. So I think this is going to be the main. Just before it calls the function, it's here. On MSVC, you have to allocate. The other thing that is confusing about x64dbg is that the addresses are on hex. So on Compiler Explorer, the addresses are going to be on decimals, but here are on hex. So the first, if it's just say it's going to be the same because on hex and decimal is the same. But this one is actually 40 bytes because it's 2 times 16 plus 8, which is 40. 40 divided by 8 is going to be 5, which is 5 rows on the stack, because each row is 8 bytes, because it's 64 bits aligned. 64 bits is 8 bytes. So it allocates these values in case the function needs, for parameters, I think. And it's just a convention when you're using MSVC. It's called shadow store or shadow stack, I think. So I think this is the start of the function there. This is the thing that I mean that it's kind of weird because I think this is going to be related to the process. So it's like a security cookie. Oh, the other thing that I remember is that I went back to the course there. I'm still going to do this again. But basically, he says that it doesn't matter what hardware you are using, you're still going to segment the process. So the process always has the different segments, the stack segment, the heap segment, the code segment, the data segment, I think. I'm pretty sure I took a picture here. Yeah, memory. So it's basically this memory layout here. Let's see if I can find. It's basically this. So every process, like the operational system creates this basically. So it's just an abstraction that the operational system is going to use to organize the addresses on the process, the virtual addresses. But the difference between the 16-bit hardware and other hardwares like 32 and 64 is that on 64 you're going to have the flat memory model, which means that you use less of the local descriptor table. And this part, I'm not 100% sure still, like exactly the nuance between the differences. But I think like they both use the far pointer, which means that you're gonna use these segments here to determine the bits on the registers that are gonna be used on the global descriptor table. Then the global descriptor table is gonna be the thing that is kind of like a massive array of addresses. And it's going to be the thing that you use to find the page, the virtual page of the process. And then from the virtual page, you go to the physical page. So it's just additional information that you use on the register. But on the flat memory model, you just have like a more direct connection. So I'm going to ask ChatGPT. I think I have asked here. I asked this before, and I went back to the video. It's kind of hard because it's hard to memorize. There's a bunch of stuff on this. I highly recommend these videos here because they are very good. But it's just extremely hard to uh, memorize everything, obviously, because there's a bunch of nuances on the bits of these different registers. But the main registers are global descriptor table and local descriptor table. And he shares a picture there as well on some situations. I think at the beginning, I think across the course, he shares a picture showing what has been covered. But I don't remember if I saved here. But I think when it comes to x64 DBG, it doesn't matter because like whenever you see this segment here and you see an address, you can find the address directly here. So the whatever number it is here, as far as I can tell, I might be wrong about this, but that's how I'm thinking about it right now. So this obviously might be some stuff related to um, protection, but I think that this is the thing is that the function should have two arguments there. So based on the assembly, just moving one. So I'm not really sure if this is the code for the actual function there. I think it's just some stuff related to the process, and then it calls the actual function. So this is probably the function. So x has one. And this is the part that is kind of confusing. That's the reason why I want to choose Compiler Explorer, because it's gonna take some time for me to be able to distinguish or like make sure that the code that I'm looking at is the function there. I still think it's not this. To push RBX. I think this is still stuff related to the process and security, and not the actual function that I have there. CPU ID talks about in the beginning of the course as well. I think that there is some register that determines the mode of the hardware. I think it's related to CPU ID. So based on some bytes on some register is gonna implement a finite state machine that's gonna change the states. I think this is cache coherence. Oh, it's on hardware. Remember now. So this is basically the image there that he shares on the course. So that's how it works, the translation. So on the process, you're gonna have the segments on the process, which are the code, data, and stack here. And these are used on registers that are used on this array here, or yeah, this array, which is the global descriptor table. So you can imagine that you have a bunch of addresses there. And then from this global descriptor table and local descriptor table, you're gonna have another register that is on this linear address space, which is basically the thing that is gonna hold the bridge between the virtual pages and the physical pages. So it's basically determined by registers and the bits on the registers. So the distinction happens on the registers and not on the segments of the process. They both have segments on the process. So just gonna continue here. I'm not really sure, like based on I think there's only one tutorial that I could find that explained the thing, the arrow here to get you the code, but I think that is not this code here. I'm pretty sure that is still related to process. I think, and not the code that I have there. It might be because I have a lot of other examples, so it might be code related to this as well. So now it's gonna call security stuff. Maybe it's calling the other functions. GS is a segment dedicated to the process environment block, I think. So this GS30 happens a bunch of times. I think I think that the 30 is the process environment block. One thing that I had wrong in my mind before is that I thought that the process environment block had the thread environment block as a value or as a member, but it's the other way around. So the thread environment block is the bigger one, and inside the thread environment block you have the process environment block. And I think that the 30 is the so whenever you see GS 30 is the process environment block. I think it's stuff related to the process environment block. I'm pretty sure I took pictures of this as well, but I don't. Maybe these ones are on the reverse engineering on this section there. So P E header. Oh, this doesn't have anything. There was a. So I remember seeing. Like, if you find, I think they have on the official documentation as well on Windows. But it's basically just a bunch of structs on C that have these values. So as far as I can tell, the Windows, both Windows and Linux, are written in C, and it's basically just structs that determine what's gonna happen. So the operating system is just gonna be the kernel, the user interface, and system libraries, and it's basically just just like any other C++ program. It has but the difference is that it has special privileges and creates the abstraction, which is the layer between the hardware and the user processes. But the way to think about it is just like a normal, just like any other C or C++ code. So this one I don't remember where I got from, but just basically all these structs connected, and this has a bunch of information, like a bunch of code that is going to determine how the process is managed by the operating system. And so I have to remember, maybe I ask ChatGPT to see. Because I don't remember if the 30 is. Yeah, typically is a process environment block. So I think that this is still stuff related to managing the process. Maybe I'll ask ChatGPT. There's another already half an hour, so I'm going to focus on Haskell now. To reach main, blah blah blah, set breakpoint main directly. The idea that I had before was to use a string. So I can find string references. But I think I'm gonna try that another time because I wanna focus on Haskell now. We don't wanna spend too much time on assembly today. Symbols. How do I open symbols? Oh, here. Yeah, I think it doesn't have anything. Whatever. So I'm going to pass F7 a bunch of times. Or F8. Yeah. So at some point there obviously ran the function, but so another time I'm going to spend. I think for the examples on multiplication, it's probably gonna be better to use x64 DBG, because it's gonna help a lot to like I just recently learned this, but you can use there's a programming version of the calculator, programmer version, and then here you can paste the values on hex. So I think it's probably gonna be better for multiplication. You just copy the values on the register, then put here and then C on decimal to see. So there are two things that I wanna figure out is that in this instruction here, it basically just is using EAX after the on the I move, but I assume it's gonna set the value on the other register as well. But just looking at the code here, you obviously can tell. So I want to see on x64 DBG what's gonna happen. And the other thing obviously is gonna be the value, just see, because if it is overflowing, then it's gonna be a weird value. But this is one of the parts that is confusing on assembly. But as far as I can tell now, the way that it works is that the representation on assembly is already on choose complement form, and what's gonna define whether or not like how the meaning of the numbers change is the kind of operation you are using and the hardware circuit. So for iMove is gonna change because the result has to take two different registers. So the iMove, the only difference between the iMove and the move is that the iMove is gonna extend the sign, I think. But this might be a problem because then you can't really look into like the values that are gonna show up on x64 DBG are still gonna be on choose complement form, and then it's up for the compiler to make sense of these values. But I think both on the hardware and on assembly is on choose complement form, and then in some operations doesn't matter that the hardware is gonna, because the hardware is always gonna accept the numbers as if they are already on choose complement form. And some operations is only gonna matter because of the extension of the sign bit, I think. But on the binary itself, it doesn't change anything, whether or not they are in choose complement or not. It's kind of weird thing to think about, but that's how I think it works right now. Which might be wrong, but that's how I'm thinking about it right now. So what I'm gonna do now is just open this folder here. And I'm going to see if I can run. I'm gonna create a file there. I'm gonna follow the simple example on Haskell. I'm gonna spend 1 hour, I think, on this. So this is the one that I was looking before. So I think this code here, this example comes from this channel here, which is very good. So he has another playlist, and he shares this GitHub repo, which has a simple implementation of some types thing on JavaScript. And that's basically this code. This is the old theory. So I'm gonna create a file the way that they hello HS. I think you need some extensions probably to get the types. And copy this code. So you compile first, it generates a file, and then you run. Yeah, okay, so it seems that it is working. I'm not gonna download extensions right now. I'm probably not gonna download because I think I disabled a setting on VS Code because the extensions require you to download stuff, I think. And I disabled a setting some time ago and don't remember how to do this, but maybe I'll spend some time. I think probably not. Because like I said, the goal is not really, but it might be helpful to understand the other codes. So I might have to remember what setting it is to disable, and then download the comic station and enable the setting again. Yeah, but it looks like this is just the only example that I have there. So what I'm gonna do is try to. Here's one question. I'm gonna ask ChatGPT because I think it's easier. So I'm gonna look into the. So I do remember now that I was gonna try. Yeah, I was gonna try to look into the simplest one first, because the main goal that I have here is to understand the application of type theory on compilers, and that's the reason why I wanna learn Haskell now, because these repositories are on Haskell. So what I was gonna do is start from the simplest one and then try to climb the way up to the more complex one. I wanna see here if they have anything on like how to compile. So this one is gonna be by the next. I'm not really sure if I think I didn't download this one. So this one is the last one there. I think this one is the one in the middle. So I think I didn't download this one. Yeah, the one in the middle. I just it doesn't have anything, but I think this one is simpler because it's just 3 files. I guess you compile the main one, let's say, and then it compiles the other ones. This might be annoying actually. So let's see. It's not. Oh, sorry. It looks like it is working. I'm gonna install Haskell. I'm gonna install the Haskell extensions to see if it's gonna put the syntax highlighter. It's gonna be easier to figure out stuff from the beginning. Yeah, like looks like it is working now. To install these ones. So I guess I'm just gonna. I kinda understand, but not really. But I think I understand the basics just from like common sense from other programming languages. But the thing that is kind of weird to me on Haskell is that from what like superficially what I've seen is that you don't really have classes. It's like pure functional programming, which means you only have functions and like the goals of not really the goal, but the way that the way that the functional programming languages are structured is that so we have functions that don't have side effects, which means the function is gonna have an input and output, and it's not going to do anything in the middle of the function that changes the global state. So in order to get around that, they use this concept of monads, which is a very complicated concept on category theory, but it's basically a structure that changes itself. So the simplest example would be a flattened list. So when you have a list, you have a structure. Then let's say you have a list of strings, and you implement a map to change the strings to integers, for example. What you're doing is implementing a function on the structure that is the list to change the objects that exist inside of the list. And then I didn't understand this part in the example that the guy talks about, but when you do that, you the result is going to be a nested list, and then if you flatten that list, you get the original list back. Then you implemented a monad, which is a function that changes this what's inside of the structure, but doesn't change the structure itself. And that's kind of the concept that they use to implement classes. So when you see a class there, it's not really a class; it's just a monad. It's kind of like a flattened map. To the best way to think about it, I think. And these arrows here, as far as I remember, I think they're like indicating the type, and they create a function. But this part I'm not 100% sure. So I think that this would be like the concept of curring, which is just a function that returns another function. Let's see if they have on the documentation. I wish they had the like straight to the points, just explain the syntax of each thing. I mainly wanna see the what the arrow does. But this is the kind of problem because I think that they are gonna have these books and they're not gonna explain just each syntax what it does. So probably ChatGPT is better for this in the beginning. Oh, so this might be good to listen to or to read. So this is apparently is declaring a variable. So this would be like the type. So obviously, like these things are very similar to the other programming languages. So I think it's kind of intuitive to understand. Let's see if I can find the arrow thing. And the hardest concept I think is monads and variations of monads, and then getting used to the syntax when you're reading the code. So this defines a function. So I think the arrow determines from also videos that I've seen before, the arrows determines the return statement. So this would be like you're declaring a function of this name that is going to accept an integer as a argument and is going to return another integer. And if you have more than one arrow here, you just basically have all parameters that the function is going to receive, and the last value that shows up is the return. So if you have if you had one additional integer here, it would be a function that receives two integers and returns one integer. And so that's basically, I think, how it works. And then here, so this would be the declaration, and then here's like the definition. So I have n plus, yeah. So whenever you call this, it's gonna replace n with this thing here, which is gonna execute the value there. And so probably that's how it works. So I'm gonna look more into this here. See if I can compile this. There's two different questions. One is how to compile the main project. I'll be right back. Let's try this. I'm gonna try to just do this simple command there to see what happens. This is a small project. So I think that the if you run this command on the entry point file, it automatically creates the object file for the other ones. It is interesting that it's not creating a executable file. Hmm. Let me see if the other ones have quantitative type here. So this one has an example. So I'll spend more time on this later, I think. I'm just gonna look into the code here. I don't remember. The thing is that there isn't anything explaining here. I don't remember how I got this. I think I got from Perplexity, searching. And later, after I watch a bunch of videos, I'm going to search for projects that are specific to certain concepts that I'm trying to clarify. So I'm just gonna look into the code here to try to understand what this does. But based on the name AST, obviously I think that this one is an abstract syntax tree. I think module is probably for importing the files. Let's see if I can. Yeah. This is one of the terminologies that I think is there, like it is kind of confusing, and I'm trying to clarify more how it works. But that's usually how they describe, because when they describe grammar, they are usually describing on a different language. So the place that I remember is the Python. So there's a, I think, I don't remember where, I think it's this one. Yeah. So this one I put the files there. So Python uses a parser generator, which is like a program that from the grammar generates the code that's used to create the statements on Python. And they use basically this file here, so it's a different language, but it's basically the same format. And the way that it works is that each one of these is going to be either a terminal or non-terminal expression. A non-terminal is just like the name says, that it doesn't finish is not an endpoint on the finite state machine. And the terminal is like an endpoint. So the terminal would be the keywords of the language, and non-terminal would be expressions, just like abstract concepts that create phrases, for example. So the non-terminals are phrases, and the terminals are words. And it is expressed on this notation here. But it is kind of confusing to understand like how does it work to create the to actually create the abstract syntax tree. But I think all that it says is that whenever you see a token that has this type, just recurse on the tree or something to continue parsing, or but I don't, it's not very clear how it works. So obviously this would be a function that takes its three arguments and returns an expression. Yeah, I think that these kinds of statements, they are used to build the abstract syntax tree based on the tokens. Just not very clear yet on my mind how the connection um, from after it creates the tokens, how it uses that to build the abstract syntax tree. So I'm gonna ask if there's an equivalence. I'll close this one. This is basically the code from Python of the parser generator. The grammar is not a part of the code. It's part of the other. So I just basically extracted the code specific to the parser generation from the main CPython implementation. But I didn't have the grammar before. The grammar is on another location, and both of these are on a folder there that Python uses. So basically, Python uses this code to generate the C++ code that is going to have the functions that are going to be used to create the abstract syntax tree. And it derives them from the grammar files. So a parser generator, I think it's PEG, the name, parser, I don't remember what the parser expression generator, probably. It's basically what Python uses to create the grammar from these files here. The Python code's gonna parse this probably and then create the C++ functions that are gonna receive the tokens and they're gonna construct the abstract syntax tree or the parse tree from the file. But I'm gonna study this later probably. So I was gonna look for a main here to see if there any of these functions have or any of these files have a main. Looks like they don't. And there isn't any description there. I'm gonna search for the whole thing here. Because this is gonna search for the other projects as well. Should probably open one at a time actually. It's gonna be easier to figure out. I think I'm gonna go over on the other one because I need to find like some place to ground myself based on the other languages, like the mental model that I have on the other languages. So it's obviously easier to try to start from like a main entry point. And it looks like here, like there's two problems with this one is that it doesn't have a description of what it does. I think this is just for copyright thing. And it seems that it doesn't have this main entry point. So I'm gonna close this one. I'm gonna open each one individually, I think. So this was the second one. I think, yeah. The problem that one is that it also doesn't have a description. So this is basically the same. Toy implementation of quantitative type theory. I think I was studying something and then I used Perplexity to find this GitHub repositories. So I'm gonna open on this one and try to find see if there is an entry point or something that I can ground myself on to try to understand. Yeah, because the goal is to understand. I'm studying the type theory when it comes to category theory and like the more abstract ideas, but I wanna ground that into code as well. So go back and forth between the theory and some code, especially when it is related to compilers. So maybe this one I can make it work with the Cabal or Cabal stuff. That's ChatGPT is on there. Let's see if this works. So this should be the entry point probably. Also, but this is on the test file, so I'm not really sure. So it should be this file, the entry point. I think what this does is call these other files here. Previous file. So the way that I see this is basically like a switch. Obviously, I'm not really sure. Maybe it's a loop and it's calling these functions. I think these are functions. I think is that this should be a task, not a main code. I think this defines a type, probably. So this defines the type, and this declares the type. What is a pattern? I'm gonna ask this one first. I'm just gonna tell it to ignore the IO, but I'm just gonna ask like this first. Also, it gives precedence to the whatever you put after, I think. So I think it's just running. This is just gonna call the functions and then runs the tasks. I'm gonna put this one there. I'm gonna ask, uh, just gonna go with this file. The main, it is kind of weird because the main should be the one that is on the task, but it doesn't, because obviously on C++ it wouldn't work like this. So I think that this is supposed to be the main, and then it's gonna run the tasks here. So like I think that the other code, like this code here, is supposed to work as a library, and then you would have to implement your own main. But since they're just using it as a library, they are implementing as a task. Just basically, these files here are probably running the functions that are going to. So maybe I should start with this one. So the way that I'm thinking about this is like selecting a file and then I'm asking ChatGPT what it does. Because obviously ChatGPT can be wrong, but I think it's just a quick way to have an idea, and then later I'm gonna watch videos. I'm probably gonna watch the tutorial here that I have open, and then read the documentation again. So I just wanna clarify this, mainly the syntax in the beginning. So I think it's including this, which is the same file. If I should try to put them side by side. So I think it is just pretty self-explanatory. I think that the syntax is gonna be the this actual. So we're gonna import this folder and this file here. So this here is gonna task obviously based on the name. I think that makes sense. So this code here tasks the code on this file, and the other file is the official one. This defines a function. Defines a function duplicator. It's for turns a doc. I think that the pretty comes from this other file here. Syntax. It might be an external library, I think. So that's pretty print library. So I think it's calling a function and then passing the pretty argument to the function. So it takes a single argument. So the whole type, that's kind of weird. So this is one type. So this it is defining. So this is one argument that the function receives and returns this. And then this one is defining this function and passing this as an argument, I think. So let's see. On the other file, what it's supposed to do. And probably studying the actual files and not the tasks is going to be easier as well. Partially applying the function, function pretend. It's presumably a function defined elsewhere. So this one comes from this file, I think. Is this function here? Mainly, I have to focus on what questions to ask, so that when I'm going over the videos, I already know what matters most to focus on. I'm gonna ask questions about this one. So one of the questions I have is it necessary to declare functions before them? Okay, so the first argument is a function, I think. So it receives this as an argument, which is a function that receives this argument and returns a doc. So the term is so whatever this term is, I think it's probably a function, and it's going to, because here is like one argument as well. So I think what this is saying is that the argument that this function receives is the term, and the term probably receives three strings as arguments, because it's probably a function as well, I think. So what this is saying is that this is going to receive a function as arguments, as an argument. The function receive, and the function that is going to receive as an argument is another function which accepts, which is this term, accepts this term, which has these three strings here, and then it's going to return a doc, and it's going to accept another argument which is just the term, and then it returns a doc. I wonder if I can find, because if I press F12 it doesn't go to the definition, so I wonder if, where can I find this? I think what this is saying is basically like, it's probably similar to Python, I think, where the first thing is the module that shows there. Then the second thing is like the dots are the paths basically to the file that it is importing. So this would be the on the text folder inside of this on this file here. And then here specifies exactly what things you are importing from that file. I think that's how it works. So based on ChatGPT response, it should come from this term here. But I want to see if I can find the source code for this. The compilation there didn't work, so maybe it is because it didn't work that it didn't install or whatever. It's a function that knows how to preprint a term in the term itself. And it produces a preprint document as output. The bound seems to come from here as well. Let's go. Let's go. Hmm. I don't think it's worth it, sure. So it looks like he shares the GitHub. It's probably not worth it to spend time now looking to these libraries. So it comes from here. Maybe if I search for the this thing here. So obviously this is gonna be coming from this library. I wanted to see where does the term come from. So I think it is likely that it is this thing here because this one imports the syntax. That's probably before this. Hmm. So that should come from one of these libraries, I think. But ChatGPT is saying that it comes from the local code. And this is the first time that it's used here. I want to see what this is so I understand what is this syntax here. Why is using three different things after this one. Because the way that the mental model that I have in my mind right now and the way that this works is that is a function that is going to receive three strings as arguments. But I'm not sure if that's the correct way to think about it. I'll be right back. I think it's more like a generic template thing. This is probably the reason why I'm struggling to understand this, that there isn't a direct relationship on C++. I'm gonna ask if it is similar to a generic type, but I think it's probably not gonna be the same thing. Parameterize type constructor. I'm not really sure. Based on ChatGPT's response, this is the definition of what the term is, but I'm not 100% sure about this. I'm gonna write down the questions. It's not really a question about the build system that I have. I think the build system is very similar to Rust, where you put on Rust is the cargo file, I think, on the root of the project, and here it is the other file there, this cabal, or yeah. And then whatever you put here is the specifications of what the project needs. So it's probably not that hard. You can just copy from this, like use this as a template. And this is probably signaling the entry points of the project. So it's gonna compile everything from there, and then modules and dependencies. So I think, and this is not very interesting to me because, like I said, my goal is not to build anything on Haskell. I just want to learn enough so I can understand this code because I'm not gonna do anything on Haskell. I just want to see. Like, the main purpose is just to have a context of some practical application of type theory. So it's like it allows me to ground the concepts on type theory using Haskell, and then I'm probably gonna continue to build. I'm definitely gonna continue to use C++ because that's what Godot uses. But yeah, I think it's probably a good idea to learn Haskell just to understand the projects and the papers about compilers. So my main goal is just to understand the language. So I'm gonna write down just questions related to the language itself, so I can read the projects and understand what it does, what they do. I think one of the questions that is worth it is to how to find, because although I think that ChatGPT is probably right, but I'm probably gonna research this later as well. But I need to think more about like better questions to ask when it comes to the organization of projects. So basically, the import system. I'm gonna search for videos. I think the first video I'm gonna watch is probably gonna be the one that I have open there. But then later I'm probably gonna look for like search for specifically these parts. And parameterize. Algebraic data type. So algebraic comes from mathematics. So and it is related to type theory, but I don't know very well how. I think it's related to topological spaces as well. Oh, so these are the constructors of the type. Instruction. So the way that kind of see it, I think it is different, but like it's similar to like a class that because it's not really a templated class because a templated class would be the same initialization with different types. But it's like it's offering different options to initialize this term here. So there's different ways in which you can initialize the term. So I think I understand how it works, but there isn't a very good way to think about it on C++. Now, It is kind of difficult. It's kind of annoying to figure this out here as well because I'm probably gonna have to look into the library codes. So probably this is a good question to ask or to research later, as I can look into the source as well there. I'm gonna write down this command. This is probably this one, I think. I think it is similar, like it is similar to a template on C++. It's kind of like generic types you can use here, and then it's gonna take whatever, depending on how you initialize the thing, is going to replace the values there. Here it gets very confusing because it's passing down there. So this example is very confusing to understand how it works. So like it's kind of hard to understand because so I think that like I'm gonna ask this ChatGPT, but I think what this is doing is basically so like this defines a function that is gonna receive the shoe arguments and it's gonna receive doc. I think what this is doing is defining the function. So this declares the function, and this defines a function math that is equal to this thing. So this would be basically the constructor of the whole thing. But it's kind of weird because I'm not really sure. And then this would be like another instance of this. So like this has the same type as this one. And this is the whole initialization of this. And this is using this case constructor here. It is very confusing. And it looks like this operator is concatenating. So concatenates the line from this pretty, which comes from this thing here, with this ident of true. And then it calls, I think, or whatever this means. So this is a call, and then it's gonna concatenate this with this. She has a line break with the indented document created from this. So f would be this function. Uh, like it's kind of confusing because I don't really know. I'm not used to this way of writing things as well. So like because there's three different things here, like the way that I'm thinking about it is that this should be a function that's gonna receive two arguments and return this. So it doesn't make a lot of sense for this should be the constructor, but it's the only thing that makes sense in my mind right now. And I also don't understand how the f is related here. Like the way that I'm reading this is that this is gonna be as if it is constructing this function. So when it calls a at case here, it is like it's running this, but it doesn't make sense. And then it's making this equal to another because theoretically this would create at the end of this expression here, we generate this type as well. Like this returns a function that is this type, and this defines the function of this type as well. using the constructor dots. But that doesn't make sense because so I have to ask this question here. I'm just very confused about the. Also, yeah. So the two things are the different parameters. So the first one would the f would be the function here, and this part would be the term. So that's why he's using the case here. So he's gonna use the case constructor on the second parameter of the function. And then it's gonna make this equal to this. So I'm not really sure. So maybe the second part is gonna be the return. I guess it's kind of weird. It's weird because it doesn't have a name here. Matches the pattern on the right. It matches A against constructor case. If A is a case term, this pattern will succeed. And A will be a bounds to that case term. I'm not really sure what that means. So, like, what does it mean for A to be a case term? I guess, like, let's say you initialize case somewhere else, and then you use that to initialize term. So on the other example there that had string, 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 it wouldn't work probably. So you need to have a situation where you pass a term where the third argument is going to be of type case, I think. Allows you to bind the whole matched term to the variable a, while still being able to use case constructor to work with the pattern. It means a contains the entire case term. The right hand side of the equation compute the outputs of the function. So it's a doc representing a new line. Calls the function f. This is the first function, argument a. So it's like that. It would be like a callback function, which is of type term. The result of fa is then indented by two spaces using pre-ident. So it's concatenating the result of calling this function, the first function, passing the argument a, with the line here. And this would be the return, which is this doc, I think. But the thing that is confusing me is that it doesn't have a name. So like, what does it mean to do this? That's the thing that is. I guess that the name would be the first thing. But the way that I think about it, it's more like this creates a type. So this would be type this. That's why it's weird. Let's see if it works. It is. So I guess instead of having the name, you use the type, and then whatever you pass uh, after is gonna be the arguments, I think. So I think I understand now. So it's kind of confusing because I'm used to thinking about the like the name of the thing, but this is the name of the thing already. So like this is defining it's kind of like defining a variable. So the variable will have this name, and the this would be like the equal, but it's basically a type instead of a value in memory. So like it's defining the type of this initially should be this, which is a function that receives two different arguments and returns this type here. And then here is the definition of the function, but it doesn't have a name because the name is already this thing here. So the name is the first thing. So the first two things are the first two arguments. So the f would be this function here, and the a at case would be this term here. So it's binding the type a of this term to the case constructor. So it matches the a with the case constructor, which is kind of a weird thing that I don't understand very well yet, because it's very confusing to understand. Because like the way that I'm imagining is that this is going to be initialized with three different types. So I guess like this just makes sure that the third argument that is passed through the term is a case constructor. And the equal sign is this expression here is going to be whatever the function returns, which is a doc. So this is what the function does basically. This is what it's saying. So and this is also a weird thing. I guess when you use this here, this would be the first argument and this is the second. So it's gonna call this here. It calls the function passing the a as argument. And then it idents this based on the logic, whatever logic is this by true, and then appends this to the line here. So I guess this is defined here. It's going to be basically the same thing where I have the two different parameters. So this would be on var here, and the other one would be this one, I think. So you should call this function here, or here, passing a as an argument. What would be a? So I guess in this case would be this, which is like, I don't know, it's very confusing. The thing is like, where is this a coming from? Is it coming from the f, or is this a here? I think that it makes more sense should be this one, but not sure if it makes sense. So it is a second argument. Yeah. I think that makes more sense. Whereas this is a function as well in the same way that the other one is. It's gonna receive two different arguments, one of this type and one of this type, and then it's gonna return a doc. So here, what is going on? I think that like the first thing would be like this part here is the first argument, probably. Which is doesn't have a name. I think that this is probably used for private variables. Like in Python, usually we use the underscore for private variables, so I think that's probably similar. So this would be defining the first argument that the function receives, which is another function. This one, and but I'm not really sure actually. I think after the equal sign it has should be no. So, I think that this is defining. How is this possible? So maybe it's like C++ when you have the same function with different types, you can define them multiple times. But I think what this is doing is like this underscore here would be the first argument, and this branch impossible would be the second argument. Now that's probably what is going on. So this is defining this function. these two different types here, two different arguments, and then the thing on the right is going to be the document that gets returned, which is this thing here. And this is defining another type that the function wouldn't have, which is the two different arguments, and then returns this thing here. So this would be a document there. It's very confusing, not gonna lie. Let's break down. So the first argument is gonna be this. So I think that these are the function is gonna receive three different arguments, and then it returns a doc. So I think that those are the three different arguments that it receives. So pvar should be a here from this function, and these three here are gonna return a document. So this is the first argument, I think. Not really sure if it makes sense. So it would be like the three different term arguments here. So this would be like n, the one in the middle would be l, and the other one would be a, which comes from this, which is the first argument of this function here. So a here would be this function here. And that does make sense. because it has to be a function that returns. So a preterm is see what it sounds. Yeah. So it is what I was saying there. According to ChatGPT, which obviously can be wrong, but I'm pretty sure that it is how it is working there. So I'm gonna stop streaming here. I'm gonna watch the video there on Haskell, and then I'm gonna look for these specific questions here. So obviously I still don't understand. Like I think just very confusing to think about it in the way that it is here. It's just a different way to uh, write stuff. Like I'm used to seeing the name, the type first, then the name from C++, and not used to this kind of declaration. And also, what makes it harder to understand here is the external libraries. But I think I'm kind of getting it, and I think it's just harder because of the nature of the code, and probably the nature of the language as well. Like where you have a bunch of functions that are used on other functions and currying as well. Just I'm just not used to. So it's gonna take some time to understand, I think. But it's becoming more clear. And the other thing that is kind of confusing is because here I'm not going over the main thing. So I'm not following the line of execution from the entry point here. But obviously, like in the beginning, it's harder because each thing leads to another thing, and everything is together. Like everything is connected to each other. So this thing is also very confusing. This is like is a generic type, and then is used here, and this one's gonna like use several different things. So I have to understand how these other things work. It's very confusing. I think like this is calling the thing recursively. In this case, so as far as I understand each one of these, it would be like a constructor that this term uses. But this is also very confusing because this is supposed to accept three different types. So I don't understand very well what that means. Because on the other example, it is passing three different things to initialize this. So how does that work? I don't understand at all. It's very confusing. And this, like each one of these would be a constructor. So this would, I'm not really sure if it would like pass or call this recursively with this other constructor here or this type. So I'm gonna stop streaming. I'm gonna search more, watch the videos, try to clarify these questions. The next time during stream, I'm probably gonna continue to do the examples on assembly, and I'm going to study enough Haskell to be able to understand this stuff here. And yeah, as I study types, I'm going to uh, go over this code to put the two things in contrast with each other, the theory and the application of types. But I'm probably not gonna. I'm gonna try to avoid spending time on Haskell as much as possible, because my main focus is C++ on Godot. I just wanna know enough to be able to understand this stuff here. So next time I'm probably gonna continue to do this stuff here, try to understand this project and study assembly x86. And off stream I'm probably gonna, not sure if I'm gonna have time because I have to study a bunch of other stuff. So see you then.